Hello, my little mathematicians. Today, I'm going to help you learn about borrowing with fractions better. Okay, so first off, let's kind of do an example of each type. So the first one, let's say we have 7 and 1/4 minus 3 and 3/4. Now, always the first step is to look to see if you have common denominators. Well, 4 and 4 are common denominators, so step one is done. Then you subtract the numerators. But the problem is when I go to subtract 3 from 1, I can't do that. So I have to borrow from the whole number, right? So I'm going to borrow from the 7, and then I'd subtract before I forget. 6 minus 3 is 3. But when I go to add 1, I don't put it as like 11/4 because 1 plus 1/4 is 1 1/4, right? 11/4 is not 1 1/4. So I'm going to add 1 as a fraction of the same number over itself because any number over itself is 1, right? Think about it. What's 5 over 5? 1. What's 10 over 10? 1. What's 20 over 20? 1. So I can put any number over itself to represent the number 1, right? But I want to be picky about what number I choose because when I'm adding and subtracting fractions, I need to get a common denominator, right? So I want my denominator to be a 4. So I should choose what over what? A 4 over 4. So that way, when I go to add 1, quote unquote, because 4 over 4 is 1, to the 1/4, I get what? Well, 1 plus 1/4 is 1 1/4, which is the same thing as 1/4 plus 4/4. What is that? Keep the denominator the same, add your numerators. 1 plus 4 is 5. So 1/4 plus 4/4, or 1, is 5/4. 5/4 is the same thing as 1 1/4. If you were to take 5 and divide it by 4, you put your remainder over what you divided by, 1 1/4, right? 5/4 is the same thing as 1 1/4. So 1/4 plus 4/4 is now replaced with that 5/4. Why did I do that? So that then I have a big enough numerator to subtract 3 from. 5 minus 3 is 2. Now go ahead and reduce that. And what's your final answer? Yes, 3.5. Because you had to ask yourself, can anything go into both of these fractions? Yeah, they're both even, so 2 can. 2 divided by 2 is 1. 4 divided by 2 is 2. And that was only affecting the fraction. The whole number just stayed a whole number. Okay, I'm going to do one more where they already have common denominators, and then I'm going to get harder. Okay, so you have 6 and 2/5 minus 4 and 3/5. So your first step is to ask yourself, do they have common denominators? Yes, they do. Okay, they both have a 5. So then you want to subtract your numerators. But when you go to subtract 3 from 2, you can't do that. You can't take a bigger number from a smaller number. So I'm going to borrow from the whole number, and I'd subtract 5 minus 4 is 1 before you forget. And then I'm going to add 1 as a fraction over a fraction. What number do you think I should choose? Hopefully you said 5 over 5 because I wanted the denominator to stay a 5, and then I combine the numerators. 2 plus 5 is 7. So 2/5 plus 5/5 is 7/5. And 5/5 is 1. So like when I added 1 to 2/5, I got 1 and 2/5. 1 and 2/5 is the same thing as 7/5. So I'm just rewriting 1 and 2/5 as 7/5. So then I have a big enough numerator to subtract 3 from. 7 minus 3 is 4, and keep the denominator the same. Okay, so we started with that. Now I'm going to show you hard where they don't have the same denominator. Okay, so if they don't have the same denominator, like this one, let's say you have 3 and a third and 1 and 5/8. Okay, well, my first step is to get a common denominator. So ask yourself, what can 3 and 8 both become? Well, bigger number is 8. Can 3 become 8? No. 8 times 2 is 16. Can 3 become 16? No. And 8 times 3 is 24. So yes, they both can become 24. Sometimes some people just multiply the two denominators, 3 times 8, and you get 24. But sometimes we can get a smaller common denominator. But if you're stuck on getting a common one, just multiply the two denominators to get it. Okay, now I got a common denominator, but I want to rewrite equivalent fractions. What fraction is equivalent to 1/3 that has a denominator of 24? Well, ask yourself, 3 times what is 24? 8. So 1 times 8 is 8. How did you go from 8 to 24? You multiplied by 3. So 5 times 3 is 15. 15 24ths is the same thing as 5/8, and 8 24ths is the same thing as 1/3, because essentially I took 1/3 and multiplied it by 1. I took 5/8 and multiplied it by 1, because any number over itself is just 1, right? And when you do 5/8 times 1, it doesn't change the value. I just rewrote 5/8 differently. I represented it differently. And if that's like hard to see that, you know that 2/4 is the same thing as 1/2. That you know, right? And so how did you get from 2 to 4? You multiply it by 2. So multiply this by 2. 1 times 2 is 2. 2 times 2 is 4. And so you took 1/2 and you essentially multiplied it by 2 over 2, or 1. And that's how we got the 2/4. So 2/4 is equivalent to 1/2. Okay? Because I know that one's easy for you to see. It's the same thing with this. As long as you multiply the same thing to the top and bottom, the numerator and the denominator, then you get an equivalent fraction. Okay, so I got a common denominator of 24. I rewrote equivalent fractions to the originals. Now I need to subtract the numerators. But when I go to subtract them, I can't take 15 from 8. So I want to borrow from the whole number, and 2 minus 1 is 1, and then I'm going to add 1 as the same number over itself. What number should I use to represent 1? Well, what do I want my denominator to be? I want my denominator to be a 24, right? So pick 24 over 24 to represent my 1. So now the denominator stays the same, and when I add my numerators, 8 plus 24 is 32. So 8 24ths plus 24 24ths is 32 24ths. Now I have a big enough numerator to take that away from. Okay, and then you have 12 minus 5 is 7. 2 minus 1 is 1. So I have 17 24ths. And can you reduce that? No, because 17 is prime and it can't go evenly into 24. So I'm done. Okay, there's one other weird one that happens. So I want to show you. Okay, what if you have like 8 minus 2 3/4? Is it possible for you to take something from nothing? No, you can't take away, you can't give away stuff if you don't have anything, right? So when I go to borrow from the whole number, I'm going to add 1 as a fraction of the same number over itself. Well, what do I want my denominator to be? I want it to be a 4. So I'm going to put what over what? 4 over 4. Now I have a denominator of 4, and I'm going to subtract these numerators. What's 4 minus 3? 1. And what's 7 minus 2? 5. Okay, let's try one more of those. Okay, so if you were to have 11 minus 6 5/9, can you take something from nothing? Okay, pause the video, try it, and then unpause it and come back. Okay, you unpaused it, you're back with us. Let's see how you did. You can't take something from nothing, so you borrowed from the whole number, and then you're going to add 1 as the same number over itself. What number did you pick? You wanted the denominator to be a 9, right? So pick 9 over 9. Now subtract those numerators. 9 minus 5 is 4. And what's 10 minus 6? 4. You'll notice I'm circling the numerators. It kind of just helps me zero in on which numbers to add or subtract, right? Okay, one last one I want to do. Okay, you have 8 3/4 minus 2. Okay, and pause it, try it. Okay, now you unpaused it, you're back with us. And you can't take something from nothing, but can you go like 5 minus nothing or 6 minus nothing? Yeah, you can do that. What's 3/4 minus nothing? It's still just 3/4. And then 8 minus 2 is 6. So like these kind of weren't the same. Like don't overthink it. You can go something minus 0. You just can't go 0 minus something. So this is when I have to borrow. This one you just go 3/4 minus 0 is 3/4. And 8 minus 2 is 6. All right, those were all the really tricky ones. So hopefully now you have a little bit better understanding. You got this. You're going to do amazing.